So here we're going to look at chapter 18, numbers 13. So number 13, they tell us we have an equilateral triangle. Equilateral triangle means that each angle is 60 degrees. They're all congruent because it's equilateral. And they tell us the sides are 0.15 meters, so they're all 0.15 meters. And at each corner of these triangles, there's a charge, different charge actually. One charge has a negative 9 microcoulombs, another charge has a positive 8 microcoulombs, and another charge has positive 2 microcoulombs. And they want us to find the net charge, the net force, actually, acting on this positive 2 microcoulombs by the other two charges. So between the positive 2 and the negative 9, we know that the force is going to be pointing towards the negative 9 because the positive 2 wants to move towards the negative 9. And between the positive 2 and the positive 8, opposites repel each other, so the positive 2 wants to move away from it. So this is the direction of our two forces, F1 and F2. So to find the net force acting on this positive 2 microcoulombs, we got to find out what F1 and F2 is. So if we start with F1, we can use the equation of K times Q1 times Q2 divided by R, which is 0.15 squared. And we plug that into the calculator, we get 7.19 newtons. And this is perfectly in the positive x direction, right? Because the way we draw it, F1 is pointing directly to the F, to the x. So then we find F2. F2 is at an angle, so F2 might be a little trickier. But F2, first we find the force. So we find the force of F2 using the same equation, K times Q1, Q2 divided by R squared. And when we plug that in, we find out that F2 is equal to 6.39 newtons. Now, since we're going to have to add F1 and F2 together, we need to find out their components. F1's easy because it only has an x component. F2 has an x and a y component, so we got to figure out what the x component is. Luckily, we know the angle is 60 degrees. We use trig. We use the sine to find the y component and the cosine to find the x. So to find the x component, we do 6.39 newtons times cosine of 60 degrees, and we get 3.20 newtons. And now it's negative because if you look at the arrow, the the x component is pointing to the left. Now when we look at the y component, we do the same thing except we use sine of 60, and we get 0.553. But again, it's pointing down, so the 0.53 is actually going to be negative because it's pointing down. So then in order to find the net force, luckily we only have two forces. If we find the net force in the x direction, we do this by simply adding the x components, which is 7.19 newtons, plus negative 3.20 newtons, which gives us 3.99 newtons. Then we find the net force in the y direction, which is 0, because our F1 doesn't have any y components, so it's 0, plus negative 5.53, which gives us negative 5.53 newtons. Then to find our actual total net force, we use the Pythagorean theorem, right? So this is what it looks like if we draw it out. We have an x component of 3.99, a y component of negative 5.53. So our total net force is here, which after we use the Pythagorean theorem, we find out is 6.82 newtons. But we're not done because we still need to find out what the angle is. So this is net force is 6.82. So to figure out what this angle here is, we use our inverse tangent of our opposite, which is 5.53 divided by our adjacent, 3.99, and our angle ends up being 54.19 degrees. And we can say south of east, or we can say below the positive x-axis. And there we have our net force and our direction.